Okay, now moving on to a little bit more of an interesting example. So this has a lot going on. So something that we need to do for this is that we actually have to simplify before we can do anything at all. So since here we have 5x plus 10, and on this side we have a minus 2x, and then we also have 7 times x plus 2, we have more than one of the same type of variable going on here. We have an x over here, we have an x over here, we have a constant term here, and we have a constant term here. We really want just one of each. And then we want our final thing to look like, well, all the x's on one side and all the numbers on the other. So that's kind of the goal here, is that we have to start off by simplifying this whole side before we can really do anything to it. So I'm going to rewrite this side, and over here we have to start multiplying and simplifying. So here we have a 7 sitting outside a set of brackets, which means we're going to have to distribute that 7. And then I'll rewrite this. So 7 times x, that gives us a 7x. 7 times 2, that gives us 14. And now we have a whole bunch of like terms on this side. So again, before we can even do anything with solving the x, we need to simplify all of that. So this side, nothing's going to change. And over here, we're going to group those x's and we're going to group those numbers together. So minus 2x plus 7, that's going to give us 5x. And plus 14 minus 4 is going to give us plus 10. Ooh, now this looks interesting. So now we need to put all of our x's on one side and all of our numbers on the other. So I like to call this letterland and numberland. That's something a teacher told me back in 8th grade. So we want to create letterland and numberland. So I kind of always like to keep letterland on the left, just because it looks nicer. I don't really have any other reason for it. So I'm going to move this 5x over to the left side because that's where I want to put it. And if I want to get rid of a 5x, I have to subtract 5x. If I subtract 5x on one side, I subtract 5x on the other. And we end up getting 10 equals 10, which is a weird thing to get, right? Because it's like, well, where'd the x go? So for this, x can actually be anything, and that's why before I say that, let me just make sure that I didn't make any mistakes. So minus 2x, 7, yes, 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 okay. So now I'll explain what this means. So basically, this means that our x's will cancel out, and that whatever x ends up being doesn't actually matter, because it gets multiplied by the same number on both sides. So no matter what x is, it remains equal, right? So this is like saying, well, if you have some imaginary scale and you have bags of candy, right? So you have bags of candy and you have, I don't know, 2 lollipops. And I have bags of candy. And I also, so I have 3 on one side and 3 on the other. And then 2 lollipops. So in this case, I have 3 bags of candy and 2 lollipops, and I have 3 bags of candy and 2 lollipops. As long as these bags of candy are identical, it doesn't matter if I put, I don't know, 50 jelly beans in a bag of candy or if I put 75 jelly beans in a bag of candy, because no matter what number I put in them, they're going to stay equal, assuming that all the bags of candy are the same type. So because this is it's the same thing. It's 5x plus 10 equals 5x plus 10. Really doesn't matter what x is. X can be anything. So that would be your answer. X can be anything. That's a really interesting example. Okay, moving on to number 6. So here we again have x's on both sides of the equality. So we are going to want to move those x's over. Something that gives me a hint of where to start. This isn't as simple, so it's not as easy as just kind of following your BEDMAS. You kind of have to have a little bit of instinct on where to start. This division by 5 is going to present a problem at some point. This is going to give you kind of an ugly number. We're not really interested in x over 5. We're interested in just x by itself. So getting rid of this 5, I would say, is your top priority. So just a little refresher on what a denominator of 5 really means, right? So if I had just x by itself, so x by itself would be x over 1. You can always think of denominators and fractions as kind of the number of pieces that something is cut up into, right? And so remember that if we don't have a coefficient written at the front, we're not explicitly stating that there's this many of something, then it's always 1. So in the situation where you have 1 over 1, well, that means I have one piece and it's the size of 1. I have not cut it up. It's not cut up into anything. This is saying, well, I have one piece of a thing that was cut up into 5 pieces. So I have 1/5. So the denominator, the way I like to think about it, is kind of like the size of, well, how small of a slice am I looking at? So I don't really care about what 1/5 of my x is. I want to know, well, what is 1x equal to? So I don't want it cut up into 5 pieces. So if this is one slice of x that was cut up into 5, I want all 5 pieces. So that's why I'm going to multiply this by 5, because I want all 5 pieces. I don't just want one piece of it that was cut up into 5. So this gets multiplied by 5 to get rid of that denominator. And because I'm multiplying this whole side by 5, I need to multiply this whole side by 5. And it's the whole side, right? So that's why we're going to put these brackets over the entire right-hand side so that we can distribute that 5 to each term. So now the satisfying part, these cross out, we get just x left over. And now 5 times 3, number times number, we get 15x. And 5 times -2, that negative belongs to the 2, we get -10. Okay, so now we are going to create our numberland and letterland. So we want all our x's over on one side, all our numbers over on the other. And so this is, you can choose. It really doesn't matter which side you want to put your letters on. I kind of always like to leave them to the left. Sometimes it turns out a little uglier, but it all balances out in the end. So here, I want to just leave my 10 here. I'm going to highlight them so I know I only want my 10, -10 left on this side. Everything else, I want to move it over. So that means I want to get rid of 15x. This is a positive 15x. I'm not saying it because it's the first term in the expression, but it is a positive 15x. So in order to remove a positive 15x, I want to get rid of it. I need to do the opposite operation. So I have to subtract it. So I'm subtracting 15x from this whole side so that I only get that -10 left over. What I do to one side, I have to do to the other. So I'm going to do -15x on this side as well. So now on the left, I'm going to be left with -14x equals -10. I don't know, I don't want to know what negative 14 of my x's are. I want to know what just 1 is. So now I have to undo this multiplication. I have minus 14 being multiplied by x. So I'm going to do the opposite operation, and I'm going to divide by negative 14. And what I do to one side, I do to the other. So I'm dividing by negative 14. And just a reminder, that was 1. So now I get negative 10 divided by negative 14. We're going to get a fraction here. If you chose to leave it as a decimal, it's going to be really ugly. It'll look something like 1.71428, blah, blah, blah. It's really ugly. So what you can do is if you get that number, press the button on your calculator that says A, B over C, something like that. It's the fraction button, and that will turn your answer, your decimal, ugly, ugly decimal number, into a nice fraction of 5 over 7. That's your answer. Okay, so this is kind of the same-ish situation where we have that division that's bothering us. So the same thing, when you see something like this, your first instinct should really be, well, that division is going to pose a problem. So we're going to start by getting rid of that. So I want to get rid of that divided by 3, which means I'm multiplying everything by 3 to cancel it out. And what I do to one side of the equality, I have to do to the other entire side of the equality. So everything on the other side is also going to get multiplied by 3, and that will get distributed everywhere. And on the right side, some wonderful canceling happens. So here over on the left, we get 3 times 4x, which will give us 12x. 3 times minus 3 will give us, 3 times minus 1, sorry, will give us minus 3. Equals, and then these two 3's cancel out, and we just get 2x on this side. So now we want to do, again, our numberland and letterland. So I'm going to have all my letters over on the left, all my numbers over on the right. So I'm going to start with my letters. Over here, I have 2x on the right. I only want numbers on the right. I do not want letters. So I'm going to get rid of 2x. So I'm subtracting 2x. And what I subtract on this side, I have to subtract on this side. So now you're going to see something interesting happen here. So 12x minus 2x, that's going to give us 10x minus 3 equals 2x minus 2x equals 0. We have a 0. That's not a problem. If you encounter a 0 at some point in your solving process, don't panic. It's not really an issue. It just means that when you have 10 x's and you subtract 3, you get 0. But we're not done solving it, so it's not the end of the world. So now we want to make the right side our numberland. So we don't want any x's there, which means that this minus 3, well, that is going to kind of get transferred over in a sense. Well, we're going to get rid of this minus 3, and we do the opposite operation. So we add plus 3. And when we add plus 3 to one side, we add to the other side. So that ends up getting fixed. We get a 3 on this side. Now we're almost there. We don't want 10 times x, we just want x by itself. So you have to undo that, that multiplication by 10 by dividing by 10. So we end up with x equals 3 over 10. And again, I would say don't change it into a decimal because this one is also, well, actually this one's not so ugly. Or 0.3. You can change it into a decimal if you really want to, as long as it's not a really ugly decimal. Okay, so this is our last example, and then we're all done. So this one has 2 denominators that are going to give us problems. So you can tackle both denominators at once if you want to. I'm going to do it one at a time so you really understand what it is I'm doing. So here on the left side, we have our 3 minus x. That entire thing is getting divided into 6 pieces. We don't want it cut up into 6 pieces. We kind of want the whole thing. So we're going to multiply the whole thing by 6. And since we're doing that over here on the left side, we have to do the same thing to the right side. So I'm also going to multiply the right side by 6. Okay, and so if this helps you remember how to do multiplications by fractions, remember that the denominator of this 6 is 1. So when you're doing this multiplication, you're only multiplying the numerator by 6. The denominator is getting multiplied by 1, so it's not going to change. So you don't need to touch the denominators here. So on the left side, this 6 will cancel. So we only have to rewrite that numerator, and everything else is going to be nice fixed. On the right side, we are doing numerator times numerator. So this 6 gets distributed over to the two numbers up on top. And then the bottom gets multiplied by 1, which means it won't change. It's going to remain 4. So you can even start by just writing your denominator 4. And now we'll do that multiplication. So 6 times 4, we get 24x. 6 times 1, we get 6. So now we have this. Again, we have another denominator that's going to bother us. So we want to do the same thing on this side, is that we want to get rid of that divided by 4. So we have to multiply the entire thing by 4. And then since we're doing that to the right side, we have to do the same thing to the left side. So we're multiplying the entire left side by 4 as well. On the right side, we're going to have this lovely canceling, so we don't have to do any math over there. On the left side, we have to do this distribution. Okay, so on the left side, we get 4 times 3 gives us 12, and then 4 times -1 gives us -4x equals 24x plus 6. And now we can finally create our Numberland and Letterland. This is going to be one time where I'm going to make an exception to my rule, and I'm not going to move all my x's over to the left because I can already tell that doing that will kind of make me do more work than I have to. So here, because this is positive and this is a bigger number, if I was to put all my x's on this side, I'm going to end up with a negative number of x's. And you really want a positive number of x's and not a negative one, so I'm going to kind of cut that step out and make it a little bit easier for me. So I'm saving myself a step. If you still really, really want to put all your x's on the left side, it just means that you're going to have to do an extra step at the end. Okay, so I'm going to start by moving my x's. So over here, I want to get rid of this because I decided that this side is going to be Numberland. So I'm undoing the subtraction of 4x, so I'm adding 4x to do that. What I do to one side, I do to the other. So 12 remains, -4x plus 4x gives us 0, equals, and now 24x plus 4x, that gives us 28x plus 6. I really want to get rid of this plus 6, since I just want my x by itself. So I'm going to subtract 6 on this side and subtract 6 on the other. So now I get 6 equals 28x. And now I only want 1x, I don't want 28 of them, so I need to divide by 28 on both sides. And you see it's going to give us a fraction, so I'm going to put that into my calculator. If you leave it as a decimal, you get like 0.214287, blah, blah, blah. So I'm just going to press that fraction button, and I get 3/14. That is a lot nicer. And that is your answer for this one. Okay, so I hope that all of that was helpful. That's the end of the video. If there's any specific ones that you found really confusing, then I encourage you to go back, rewatch just those ones, and I will see you in the next video. Don't forget to like and subscribe and hit the little bell. All right, see you in the next one.